round of study. Our project is conducted by Diploma in Mathematics and Science students from RCDCS 143D, and it was carried out at UiTM Arau Perlis. The focus of this study is to explore how the concept of probability appears in everyday life. One of the simplest examples is our daily use of social media. So for this project, we choose to identify which social media platform is most preferred by students, Instagram, TikTok, or Twitter. The main aim of this project is to understand the pattern of social media usage among our classmates and to apply probability concept to analyze it. The purpose of the study is to highlight the importance of probability in making decisions, predicting outcomes, and understanding in real-life trends. Throughout this project, we use several statistical concepts such as frequency distribution, probability, and hypothesis testing. This concept helps us interpret the data more accurately. For the method of data collection, we used a Google Form survey. The responses were then used to identify the most popular platform and to calculate the probability of a student choosing each platform. This method is simple, efficient, and suitable for our analysis. For the population of study, it refers to the entire group that is relevant to the research. In this project, the population consists of students from RCDCS 1433C and RCDCS 1433D. This group is manageable, relevant, and provides enough data for probability calculation.
Now, I'll be talking about the importance of social media. Social media is a big part of daily life, especially for students. We use platforms like TikTok, Instagram, Twitter, or ads for different reasons. TikTok gives quick entertainment, Instagram focuses on visuals, and Twitter is used for updates and information. Social media also change how we communicate because everything is faster and easier through messages and comments. It provides entertainment, helps us relax, and gives us instant access to news and information. Besides that, many students use social media for learning, like watching study tips or educational videos.
Next, I will continue with the objectives of study. The first objective of this project is to record all the possible outcomes of students' social media preferences. This includes identifying whether students prefer TikTok, Instagram, or Twitter. The second objective is to calculate the probability of getting each social media preference based on the data collected from our survey. This helps us to understand how likely each platform is chosen by students. The third objective is to differentiate between experimental probability and theoretical probability for each social media platform. Through this comparison, we can see whether the actual result from our survey match the expected probability for TikTok, Instagram, and Twitter. These objectives help guide our project and allow us to analyze the data more accurately.
Significance of study. The purpose of this study is to understand which social media platforms students from RCDCS 1433C and RCDCS 1433D prefer the most. Since social media plays a big role in our daily lives, especially for communication and entertainment, it is important to know which platform students use the most. From this study, we can see the trends and behavior of students regarding their online preferences. The result also help us to identify which platform would be the most effective to use for future class announcements or group activities. At the same time, this study allows us to apply basic statistical concepts such as data collection, comparison, and probability. So overall, it gives us both academic understanding and practical benefits in making better decisions.
For this section, we conduct a short survey using Google Form to identify the favorite social media platform among students from RCDCS 1433C and RCDCS 1433D. A total of 30 students were selected to represent the sample for this study. First, our population includes all students from both classes. From this population, we select 30 students as our sample. The sample space for our study consists of 3 social media platforms, which are TikTok, Instagram, and Twitter. Based on the survey response, 4 students choose Twitter. The majority of the respondents select TikTok. Meanwhile, 5 students choose Instagram as their preferred platform. So, from this experiment, we can identify which platform is the most preferred among the students involved.
For this slide, we will be presenting the results of our experiment on social media preferences.
In table 9, we have three social media. Okay, first, you can see that TikTok has the highest actual preference, which is 21. Out of 30 trials, TikTok was selected 24 times. This shows that TikTok is the most dominant and most preferred platform among our respondents. Next, Instagram has an actual preference of 5, and in the experiment, it was selected only 2 times. This indicates that Instagram is less preferred compared to the TikTok. Last but not least, we have Twitter, which has an actual preference of 4 and was selected 4 times during our trials. So this means the result of Twitter is consistent with the actual number of preferences. So overall, Table 9 clearly shows that TikTok is the most popular social media platform among the students in our class. Next, we move on to the experimental probability. Experimental probability is based on the actual results from our experiment. In other words, what actually happened during the 30 trials. For TikTok, it was selected 24 times out of 30, so the experimental probability of getting TikTok is 24/30. For Instagram, it was only selected 2 times out of 30, so the experimental probability is 2/30. For Twitter, it appeared 4 times out of 30, which gives us an experimental probability of 4/30. So this value presents the real outcomes of our experiment. Next, we will compare the experimental probability with the theoretical probability. Theoretical probability is based on the actual number of preferences from our class, meaning what we expect to happen and what happened in the experiment. So for TikTok, the theoretical probability is 21/30. For Instagram, 5 students prefer it is 5/30. And for Twitter, 4 students prefer it, so the theoretical probability is 4/30. These values show what should happen in the theory based on their class preferences. For this slide, I will explain the difference between the experimental probability and the theoretical probability for TikTok and Instagram. For TikTok, the experimental probability is 0.8. The theoretical probability is 0.7. When we subtract them, the difference is 0.1 or 10%. This means the actual result is slightly higher than what the theory predicts. For Instagram, the experimental probability is 0.067. The theoretical probability is 0.167. The difference is also 0.1 or 10%. This shows that Instagram's actual results is lower than theoretical expectation. For Twitter, both the experimental probability and the theoretical probability are the same. So 4 out of 30, which is 0.133. So the difference is 0 or 0%. This means the experimental results match the theoretical probability perfectly.
For the conclusion, our study successfully identified the most preferred social media platform among students from RCDCS 1433C and RCDCS 1433D. Out of the 30 students, most choose TikTok, while 5 choose Instagram and 4 chose Twitter. This showed that short and interactive content is the most appealing to students today. We also compare theoretical and experimental probability, and the results show that real-life outcomes don't always match theoretical expectation. This is because of factors like sample size and individual preferences. However, it also shows that the most trial we conduct, the closer the experimental probability gets to the theoretical value. Overall, this study helped us understand students' social media habit while also strengthening our understanding of probability through real-life application.
Now, we are going to explain question set 2. The question states a random variable x has probability density function given by fs equals to 3/50 x squared minus 4x plus 5 for 0 less than x less than 5 and fx equals to 0 otherwise. The condition 0 less than x less than 5 tell us the function only applies between 0 to 5. Outside that range, the PDF is 0. When the question asks to calculate EX, it means find the expected value or mean of x. For a continuous variable, the expected value is defined as EX equals to integration of negative infinity to positive infinity as f(x) dx. So, we set up the integral, which is segregation of 0 to 5 as 3 over 50 x squared minus 4x plus 5 dx. Next, we factor out the constant of 3 over 50. Next, we integrate term by term. Next, we evaluate from 0 to 5, which is plug in x equals to 5 and subtract value at 0. So, the final answer is 25 over 8 or 3.125.
For question B, find the cumulative distribution function of random variable x, fx. I will explain how to find the cumulative distribution function or CDF from the given probability density function or PDF. To get the CDF, we integrate the PDF from negative infinity up to x. Because the PDF is only defined between 0 and 5, we must split our solution into 3 cases. For the first case, when x is less than or equal to 0, the PDF has not started yet because the function only exists for value greater than 0. So, there is no accumulated probability. Therefore, the CDF for this region is simply fx equals to 0. Next, for values of x between 0 and 5, we actually need to integrate the PDF. The PDF is 3 over 50 t squared minus 4t plus 5. So the CDF becomes the integral from 0 to x of this solution. First, I take the constant 3 over 50 out the integral. Then I integrate each term separately. After integrating, I substitute the limit from 0 to x. At t equals to 0, the whole expression becomes 0. So we only need to substitute x. That gives me 3 over 50 x cubed over 3 minus 2x squared plus 5x. Then unsimplify by multiplying the constant inside, and I get the final expression for this case, fx equals to 1 over 50 x cubed minus 6x squared plus 5x. For case number 3, when x is 5 or larger, we have already accumulated the entire probability. If we substitute x equals to 5 into our expression, the value becomes 1. So for any x greater than or equals to 5, the CDF is equals to 1. So the final CDF as shown, and this is how we find the CDF from given PDF.
In this slide, we are asked to find the value of Px is greater than 2.5, and to do that, we use the cumulative distribution function Fs. First, if we rewrite the probability, only need to calculate f2.5. Using the given CDF formula, we substitute the value into f2.5. After dividing by 50, we get f2.5 equals to 0.3125. Finally, we substitute this back into the formula, which gives us Px is greater than 2.5 equals to 0.6875. So, the probability that x is greater than 2.5 is 0.6875.
For this part, we are asked to find the probability that x lies between 1 and 2.5 using the probability density function fx. To find this probability, we use the definite integral from 1 to 2.5 of fx dx. The function given is fx equals to 3 over 50 x squared minus 4x plus 5. So, we set up the integral from 1 to 2.5 and integrate the expression. After integrating, we substitute the upper limit 2.5 and the lower limit 1. Then, we subtract the two values to get the final probability. The final answer is approximately 0.1125. So the probability that x is between 1 and 2.5 is 0.1125.